So let's get started. Why should I learn programming? Obviously, you're all here because you know that you want to learn programming. You heard about it from your friends or something like that. It's perfectly cool. So I'm going to try to get you even more interested. And what do I mean by that? Well, for starters, programming is all pervasive. It's everywhere. And it's in your lives. And we don't really do much with it. Now, what do I mean by that? So there's a huge gap in technology and what we have at our disposal. And what we know how to do with it. Because, for instance, people at NASA 50 years ago would have killed to have what we have in our phones. And we kind of use them to play Candy Crush. It's a bit sad, but I'm kind of trying to teach you guys to get excited that programming is something that you can do easily. It's a very learnable skill, and it empowers you. It is so good to be able to say, I have this idea. I put it down somewhere, and I really want to do it. But I just didn't have the time, and I don't know how to materialize it. Well, programming can help you there. And ultimately, you're lazy. And what do I mean by that? Well, programmers are actually some of the laziest people on Earth. And I probably heard that 100 times, but hands down, my favorite quote that I've heard is, if you're finding a task difficult, then just hire a programmer to do it. Because hire a lazy person to do it, because they'll just find a faster way, an easier shortcut to doing the thing. That's pretty much it. That's what we do. Cool. And finally, like the little stick figures say up there, why should I learn to program? Well, some people 100 years ago were questioning why should they learn how to read? Why shouldn't they have someone read for them always? Clearly, that didn't turn out for the ones who didn't learn how to read. Good. These are two of my favorite quotes. I'm going to briefly say that Richard Feynman is one of my ultimate favorite figures. And he talks about the pleasures of playing with computers. And what does that mean? You kind of get a kick out of it. It's a challenge. And it's basically like you were a kid and you loved discovering the new puzzles. There's this little thing that you just get to play with it. And it's enjoyable. So, okay. Who has ever heard that you have to write like 1,000 lines of code, like in the Matrix movies or all those coding crazy people? Anyone? Anyone feel that they have to be like speedy? Cool. I respect that. Everyone knows what programming is about. But yeah, in a nutshell, it doesn't mean writing a lot. A lot of the things that you'll see is actually someone just looking at the computer and going, oh, copy, paste. There. What do I need? Copy, paste. That's the gist of it. And one of the ones that I really want to stress is that you're not allowed to make mistakes. Everyone thinks that they're not allowed to make mistakes, that, oh, they have to get this completely right. You don't. Because you're actually encouraged to make mistakes. That's how you learn. Because if you don't encounter an error, then you won't be questioning yourself. What has gone wrong? Like, why has this gone wrong? And ultimately, when you try to Google up the answers, you'll figure out that it was actually way deeper than you actually thought at first. Cool. So what is the scope of this workshop? Like someone asked here, why is this like, if I know programming, why am I here? Well, this workshop is to get you very psyched. It's to spark your interest, and you want to go home and prop up your, look at all the links. Just go on Google, say, I want to learn more. I want to learn more after this workshop, because essentially I want to get you building stuff. I want to get you thrilled of the idea of coding. And it is an overview of programming. And what do I mean by that? I'm going to teach you the basic concept, sort of the basic ingredients, so they say, when you're trying to get your first recipe started. Why not? I'm teaching you the ingredients, but I'm also teaching you how to use them. I'm going to use a lot of analogies today. Feel free to question any of them. Raise your hand at any point, or not even raise your hand. Shout at me if you don't understand something, if you think I'm going too slowly, if you think I'm going too fast. Feel free. It's going to be very interactive. You're, that's it. Good. So, what is programming? Now, you've probably heard the first one quite a lot. It's talking to the computer and telling it what to do. But what does that really mean? Well, to be fair, the computer kind of understands ones and zeros. We respect that. We get that. But what are these ones and zeros actually doing? Basically, what the computer is, it's nothing magical. That's it. The computer is taking something that you wrote because someone bothered to translate all of that funky stuff right there. So someone dealt with all of the complexity for us beforehand so that now we're going to write words. We're going to put them in almost sentence-like forms, and everything that is, everything that is over there is of no relevance whatsoever to this workshop today. Okay, what else? Programming is, like I said before, a way of sparking your ideas, of turning them into reality. And ultimately, it's kind of a way of thinking about a problem, because when you learn programming, you actually learn how to split a problem into tiny little pieces and solve them one by one. Because if you have this thing, if you have this task that's like, it's so long, I'm never going to do it. But if you learn how to split it into tiny pieces and do them one by one, then you'll realize that it was actually really easy to begin with. You just had to do it. You had to break it. And as a really good example, a thought experiment that people love to do is, how would you explain to someone who's never tied their shoelaces before how to do it? Surely you got to break it up into tiny little steps. Cool. So that's about it. Let's get started into the building blocks of programming. Now, there's two basic aspects that I want to touch on, and they're called data and instructions. I'm going to hit a lot of buzzwords in this session. So if you don't understand anything, if you caught me saying a word that you didn't know or I didn't explain before, please say so, because I'm happy to explain at anyone's pace. Again, yell at me if I'm going too slowly or if this is too trivial. So data we like to think of as nouns, and instructions we like to think of as verbs. And you kind of get the feel of programming is basically making sentences with nouns and verbs. That's it. So when we'll be talking about data, you'll hear a lot about variables, and you'll hear a lot about data types. And the same goes for instructions. There's two key buzzwords that you'll have to remember. It's control structures and functions, or subroutines, or methods, or whatever someone likes to call them. You'll get fighting with people a lot about how stuff are called. They're all doing the same thing, though. So there are all these programming languages, right? You've probably heard your friends talk about it. You've probably seen on the internet, oh, this programming language is better than this other one. But they're all just a bunch of trade-offs, essentially, because one language is better than the other. Maybe you convey romance better in French, but you convey technical terms better in German. It doesn't really matter that much what language you learn. What I'm trying now to do is teach you kind of the basic concepts without taking into consideration any of the languages. Because for instance, like if you want to go crazy with programming on Apple, you want to get your app up on the next big app on the Apple Store. There you go. Program in Swift. If you want to get doing machine learning, go into Python. If you want to do your own thing, feel free to go Visual Basic. Everyone's free to choose their own programming language. What I'm choosing to teach you guys today is in JavaScript. So why JavaScript? Well, first, JavaScript has seen a huge rise in popularity over the past years. Literally, huge rise. The community as well is incredible. So maybe some of you have heard about Quora, Physics Stack Exchange if you're mathematicians, Math Stack Exchange, so on and so forth. Basically platforms where people ask other people questions and they get answers. So for us, that is Stack Overflow for programmers. So let me just show you Stack Overflow quickly. It's basically this. You ask a bunch of questions of people and you get all the answers you're looking for and more. The answers you didn't even know you were looking for. Cool. And JavaScript is also incredibly scalable. What does that mean? Well, it started off as being actually a web tech, a web language, but it turned into so much more. Now you can do full applications with it, just like that. because people love it, because it's very easy to use. Which gets me back to the beginner-friendly and hackathon marvel. Now, what is a hackathon? Maybe some of you have heard me talk about that at the Freshers Fair. Does everyone know what a hackathon is? Does anyone care what a hackathon is? I'm not seeing nods, I'm not seeing hands. I'll assume people know what a hackathon is. It's basically a coding sprint, but you're going to be able to use JavaScript to build something, anything. After you get a bit of the hang of it, you're going to be able to build your own little app in less than 12 hours if you put a bit of Googling into it and a bit of skills. So that's it. And it's also very beginner friendly. Now, if you don't believe me, we'll just get right onto it. So without any further ado, let's go up to Google and start playing around. So what I love about JavaScript and why I actually chose it is because it's as easy as getting up your console, isn't it? It's just that. So why don't we go ahead and write something? It says on the slides, you can go the old-fashioned version, and you just go up here, and you say right-click. You say right-click. You say inspect, and then boom, you go into console, and that's it. Or you can just start being, crazy little coder all the way, and just go Control, Shift, and J on Windows. Or, Control, Alt, I on Apple, so on and so forth. Cool. Is anyone up and running with the console? Is everyone happy with the console? Cool. So this is the first thing. You can write an alert.
Okay, everyone, just listen.
So if everyone will I'll try to do everything at the same time as you guys do, but feel free to stop me and say, can you please repeat? So if we do an alert, what happens? Look, a box popped up. This is the first thing. This is the first code line, if you've ever written, say. But what did that do? That's not very informative, is it? We may like to have the little box tell us something, because that's what this alert keyword does. Now, you'll hear me saying a keyword. A keyword is essentially, sorry, yes?
The writing's quite small. Could you zoom it in a bit?
Is that better? Does that look good? Beautiful. So you'll hear me saying keyword. You don't have to worry about that. Keywords are generally stuff like alert. You'll hear the word maybe others say like, sorry?
Console.
Yeah, like console. They're basically stuff that have been defined by people, and the ones who are working with them know what they mean and know not to use them for any other purpose than what they've been made for, because they're key for that purpose. So let's try to make this box a bit more informative, and how we can do that is actually we can write something in between the open and closed brackets, which is basically telling my little box to say hi. Now, my little box said hi. This is great. Like, you've gone a lot of steps closer to understanding what's going on under the hood. Because like I said, the computer is interpreting this, putting it through its own little magic filter, compiler, and it's running it down, and it's making the box pop up. Good. So, yeah, we can do a lot of other stuff with our alert box. I'm just trying to get you a bit happy. Very long text. So you can write full sentences. You can even write a full paragraph if you feel like it. But this box is not very interesting now, is it? Because, okay, I can write in the box what's happening. But you know what you can do? You can use a bit of user input. Now, what do I mean by that? We got another box up. The keyword prompt got us with a box in which we can type stuff. And what I did, I just typed my name and it appeared in the console. Now, my prompt took my input, my text that I wrote to it, and it put it out in the console. But my prompt can do more than that. So what you'll see in this console, which I really love, is if you'll go up and down without arrows, you'll see your latest kind of instructions, if you will. You'll see what you did, and you'll be able to redo them. You won't have to type them out every time. This is one of the great things about programming. You won't usually have to type out a lot. But yeah, so let's make our prompt be a bit more informative, say, and now I kind of know what my prompt wants from me. So I'll just go like, yeah, that sounds good. My prompt understood it. Obviously, I can use my prompt with a bunch of other things, and they'll understand it. That's it. Also, a really quick thing that you can do up here in the console is if you want to make your whole little Google page disappear, go ahead and do document.write and write something. Yes, I'll get to that. I'm very sorry for that. So, I've just written a bunch of done. My thing is gone. That is one of the powers that you have when you're writing here in the console. Like, believe me, you don't think it's much now, but it's incredibly empowering to add poop to every header in any web page, to be honest. It is an incredible power to have. You asked about the semicolon, so I'm glad you asked, because if you do semicolon, like I said before, your computer understands words, nouns, verbs in sentences. But obviously you're not going to write a really, really long sentence. You kind of have to use punctuation marks. And this punctuation mark is actually the semicolon. So when I do alert, semicolon, and then I can do even a prompt, then what this does, it does them in a sequence. It does them one after the other, i.e. my computer understood that I meant, here's the sentence. When you see the semicolon, you kind of stop, you understand what I wrote before, and then you go on to understand the next sentence and the next sentence after that. So the semicolon is basically a way of telling it, wait a bit, do this thing that I've told you to do, then you can move on. Good. So, are we all happy with how alert, prompt, of how we can do a bunch of stuff in the console already? So you're basically programmed, you know? Like, you've basically done code now. That's pretty good to me. I like it. I like JavaScript in that sense. It's very happy. It's very user-friendly for that matter. Good. So, let's get going. Hey. So, what did I just use? Because I used hi, right? I used hi. I used a for. Now, we're talking about data, and like I said, these are the basic things that we're going to be interested in. They're numbers, strings, and Booleans. And hi was just a string. A number is for. We're all happily familiar with numbers, and Booleans I'll talk more about later. But basically, under the whole thing, they're all values. And we're going to be working with values. We're going to be executing instructions and working with values. Now, what's a variable? So, like I said, it was great having the prompt and all, because imagine you're writing something that's kind of interfacing with the user. So you're writing a new thing that's getting you user information like their name, their date of birth, their email, and so on and so forth. And you want to keep that information. So if you write, for instance, prompt, again, like I did before. Oh, okay. That's not very good. Okay, so if you write prompt, and you say, if you write a prompt, and you say the name, then it'll just print it out there. But actually, you didn't really save it anywhere. Because if you want to use it after, if you want to use it later, it's not going to be helpful for you. So what I'd like to introduce you to is this incredible concept of variables, which are like containers. So you can put any value that you want in these variables, and they will be your go-to point when you want to get back that value, to use that value. So a variable has some very important things, like I was talking about keywords before, right? Remember, var is also a very important keyword. Variables, so when you want to make a variable, you're going to use var and give it a name. Now, what is writing var and giving it a name? So writing var my number and equals 4 is doing basically the following. It's declaring my number. It's saying that my number is a variable that is called my number. That's its label. And it has a value. It has the value 4. Is that okay? Am I going too slowly about this? Is it the right pace? Good.
Does anyone have any questions?
Yeah, does anyone have any questions so far? Good. I'm glad. So, okay, what can I put in there? So, like I said, basically anything. For now, what we're interested in is numbers, strings, and Booleans, like what I talked about before. And again, like I said, I can now use my number whenever. So if you go ahead and write any other variable. So if I write var name equals prompt and name, obviously I know how to type. So if I write var name equals prompt and name, and now this is doing the same thing on the surface, but actually, if I write the name now, you see nothing appears right there. Now why is that? Well, the funny thing is that now I've saved whatever I put in that prompt and name. So name is my variable that I can use wherever, anywhere in my text, anywhere in my code later on. So I can do alert and name. And funnily enough, it writes my name out because it remembered that name had the value Lucia in it, or any text for that matter. Cool. So I want to briefly touch on a very important thing about programming, and that is comments. Now, comments are very important for several reasons. One of them is that it just helps you understand what's going on. So whenever you'll see a bit of code that'll go like, oh, here's a bunch of code, and you go, well, what is that? I don't understand what that is. Well, you'll have this really cool thing that there will be a comment explaining why a decision has been made the way it was made. What drove the person who wrote that code to do it in that particular way. And it can be very useful for you in the future as well. So imagine you're writing something right now, and you're making a decision. Say, you're writing and you're changing the date for some particular fixed event. And you say, I changed the date because. Now, this is essentially the same thing as you're doing in code. You're saying, I changed this variable, or I made this thing in my way because I wanted to. I'm making it, am I being clear? Because comments are really very important, not only for reading what you've written, but actually remembering long afterwards, because you may not remember what you wrote 1 month from now or 2 months from now. For instance, personal example, I wrote something half a year ago, and just recently I wanted to modify it, and I had to spend about 3 hours just staring at the damn code and wondering, what was in my mind at that point? Why did I make that decision? It's kind of it. It helps you down the path a lot. And essentially, again, I'm stressing out the fact that now I'm not teaching you a programming language itself. I'm just teaching you the basic concepts in JavaScript. But what I actually want you to do after these sessions of workshops is be able to go on the internet, see any code, and sort of understand it. Basically, not only teaching you how to speak in a new language, but also how to read when other people write the language. And reading comments and understanding what comments are is actually one of the really important things that you will learn in your coding life. Believe me, really important. Good. So let's go away from that and let's talk a bit about numbers now. Obviously, we've all worked with numbers. That's all cool. They're numbers. The buzzwords are, I told you I'm going to teach you a lot of buzzwords today. So the buzzwords are the whole numbers, which are like 0, 1, 2, minus 3, are called integers, and the decimal numbers are called floating point numbers. And that's anything literally that has a floating point in it. It's kind of self-descriptive. Good. So, operators. This is where it gets really interesting because, like I did before, right? Var my number was 4. So now I can do another thing. Now I can write var double number equals. There you go. And now I have a double number. I want to also stress out the really, really beautiful other feature that I have, apart from the scrolling through your last coding lines, which is the autocomplete. So if you have your name, it already does it for you, and so on and so forth. The autocomplete, which is usually useful to use the tab for, is something that you will learn to love, and you might already love it already. I apologize, I'm a bit nervous. This is my first time ever hosting a workshop. Okay, you can alert on your number, and that's it. Okay, let's talk operators. So we want to do stuff, right? We want our code to actually do interesting stuff. So what we can do is we can use the operators. So we're all familiar with plus, minus, multiplication, division, modulus, division, remainder. Hopefully everyone's okay with their first year maths. It's, programming. If you think about your calculator, if you think about the calculator on your machine or on your phone even, what does it do? It just literally takes, so if you want to make the sum, it takes two numbers, multiplies them together. And it does that. Now what did that do? Took the value 1, took the value 2, took the plus operator, put them together, and they put them in the variable called sum. So that's good. That's all good, but where do I need it? Like, when will I need this? You'll be dealing, hopefully, with a lot of calculations or not. You can be only dealing with text. It doesn't really matter right now. Okay, so I told you again, I want to teach you to read code. And you will encounter a lot of this in your journeys through programming. And what do I mean by that? Well, usually people are lazy. I told you, programmers are really lazy. They love to shorthand everything. And you probably love to say TTYL instead of talk to you later, or K instead of OK, even, because that's shorter, and all of those things. Well, these are just shorthands for this. And you'll see a bunch of this. So I want to tell you where it would be useful, how it would be useful. Because, for instance, if you have your var sum equals, say you want to start at 0, and you want to keep adding stuff to sum. Well, you don't always want to do don't always want to do sum about 0 plus 1 plus 2 plus 3 plus 4, yada yada yada. You get the idea. You don't always want to write everything that you need in a line. So what you can do is, in pieces of your code, you can do sum plus equals to 5, and then that, fairly enough, assigns sum, the value that sum had before, plus an added value to it. And that's all there is to it. No, you don't. No. So you can code up. So the question was if you have to put spaces for everything. And no, you don't. You can do var equals 1 plus 2, and that's perfectly correct. Oh, wait. Okay, never mind. Okay, so you can do that. And now, funnily enough, name is 1 plus 2. It's perfectly decent. And that's JavaScript for you. But what I want to talk to you about now is actually this bit right over here. Because, you see, we have these things called strings, and they're basically plain text. And plain text is what we're going to use most of the time. So like I said, you may encounter doing calculations, but you may also encounter using a lot of text and manipulating text and so on and so forth. And if we go right ahead and just write up, I've super used name right now, but it doesn't really matter. So yes, again, the question was if you have to use spaces. No, you don't. No, you don't. But it's generally a good coding practice to use spaces. Good. It's generally much more visible that way. That's what I'm trying to get at. Okay, so name plus is, and what I'm doing right now is I'm actually concatenating strings. And what do I mean by that? I'm putting them together. I'm adding values to each other because the operators are very nice, because you saw that there are arithmetic operators, but actually in programming you see a lot of working with the operators on other values as well. So you will want to be dealing with a lot of text in the future. And that means that using these operators, the most useful one is the plus equals operator, because it allows you to kind of spread your lines or what you want to do throughout your code. So for instance, yes? So the point is that you don't necessarily, unless you're trying to convey two things at the same time. So I said that the semicolon is the punctuation mark, but whenever you hit an enter, JavaScript understands that you meant now do this. So if I wanted to say var name equals I, and if I wanted to do another thing after it, and I was like var number equals 6, then yes, I would have to put that semicolon, because otherwise, if I didn't put that semicolon, it would just like, it would throw an error at me, because it would say like, what do you want from me? Like, you told me that, and then you go like var, and var is a keyword, and I already saw the keyword before. I already kind of know what I want to do after seeing var, and I'm just confusing it if I leave it like that. No. In JavaScript, you don't necessarily, unless you want to put them in the same line, because JavaScript is a bit more user-friendly, like I said, and it kind of understands that when you put a new line, like an enter, you actually mean that you want it to go forward to the next thing. Yeah, and let me show you a quick example where you can actually use this plus equals operator. So say you have your hours, minutes, seconds, and so on and so forth, and you want to get them up. Well, that's pretty easy. You just go var total seconds equals maybe 0 right now, but then you go total seconds equals plus equals, say 100 minutes times 60, and then maybe say 24 minutes. I'm going to say 24 minutes times 60, and then total sec, you're going to take maybe hours, so it's going to be roughly 2 hours times 60 times 60. And that's going to be it. That's going to be your total number of seconds. So you've just kind of gotten the idea of how you can use this to get a lot of information in the shortest way possible. So where I want to get at next is Booleans. Booleans are really, really good for checking if something is what you expect it to be or not. And what do I mean by that? Well, you may want to take different decisions based on kind of different opinions. So as you know, you'll put your scarf on if it's cold outside. You won't put it on if it's 30 degrees Celsius. That kind of stuff. So you want to make decisions. That's where these Boolean things come into play. And they're essentially just two words. It's either true or false. And these two are another two keywords. Very important because they're the closest you're going to get to 1 and 0 in the programming, if you will. So let's go ahead and see something and see what Booleans are all about. So if you go ahead and write var is to less than, greater than. Let's do the slide example. So you go ahead and write is to greater than 3. Greater than 3. Now what I did here is actually I said, okay, 2 greater than 3. You're going to look at that and you're going to tell me if it's true or if it's false. So that, happily enough, says false. Otherwise, we would have been in a bit of a pickle because we wouldn't have agreed with the computer. Okay. Again, you can do it not with a variable. You're not obliged to use variables, especially in the console. You're a free person to do whatever your mind tells you to. You can even do this. And this is going to throw an error. Because when we use the equal means I'm assigning this value. I'm assigning the right-hand side to the left-hand side. And JavaScript, or any programming language for that matter, will not allow this. Because you're saying, no, this is already a thing in its own. 2 is already a value. You can't assign a new value to me. I won't let you. But if you're doing the equals, like I showed you beforehand. No, actually, I'm going to show you. So if you're doing the equals, that actually means that you're checking for equality rather than assigning something. Alternatively, if we write 2 doesn't equal 3, funnily enough, 2 doesn't equal 3. It's true. Our program is happy. And you've got another bunch of examples right here, but you can also think of some yourselves. So for instance, one thing I really, really want to stress is that you can check for equality between strings as well. We can check for equality between Booleans as well. We can check for equality between everything. Funnily enough, true equals true. I'm very happy with that. But yes, essentially, equality or checking conditionals, Booleans that is, are one of the most useful things because it actually allows you to put conditions on your code. But more of that later. So, the main bit is that I would really like to talk to you guys about functions. And if you go right ahead and go to this program right here, so you'll see that I've written a bunch of functions for you guys. One of them is actually the example. So the first one is actually the example function. Now, what do I mean by functions? So functions, a function is just another keyword. So why do we need them? Well, a couple of good reasons. First, they are reusable functionality. And I want you to think about this for a second. You've got a food processor, and you're giving it an input, i.e. you're giving it some fruits and veggies. You don't care how it's getting you the... Sorry. So how you get to this, good question, thank you very much. So how you get to this REPL is actually you come back here, and you see next to the slide deck is the function playground. And that's where you get to this guy. So, cool. Functions, and why do we need them? So, like I was saying, you've got your food processor, and you know what you're giving it. You're giving it fruit and veggies, and you know what you want. You want them all chopped up. But you don't really care how they're doing it inside, do you? Like, you don't really care if they're chopping up vertically or chopping up horizontally or whatever. You just care that you're giving it something that you know. You're getting something that you were expecting, and that was it. The middleware doesn't matter for you. That's what we want. We want a lot of reusable functionality. You don't want to be rebuilding the whole food processor every single time you want your fruit chopped, for instance. It's kind of the same principle with functions. So why are they really, really useful? Was like I was saying, they abstract away. Now, what do I mean by abstract? Abstract away is just dealing away with the complexity that is inside that little black box. Because for all intents and purposes, we don't care how many of the things are actually built inside. We just care that whatever we give it and whatever comes out, we knew that that was what we wanted. And fundamentally, like I gave you the example before, if you got a big problem, you got to split it into parts. And functions are incredible for doing that. They are the best, i.e., you have a huge problem, you'll split it up into 3 different functions, and they will solve your problem. So, if we go right ahead to these examples, you can try to go ahead and find a pattern, if you will, between all of them. I've already hinted at the first common pattern, which is the keyword function used in all of them. If you can find something else, that will be perfect. If there are any questions so far up to this point, no? Good. So, we can think of conditions in which we would use each of the ones. So, for instance, the first one is time to school. And time to school you'd presumably want to know what speed you're going at and what's the distance to school. And what this little function can do is actually it's going to tell you how long it's going to take you to get to school, in a nutshell. The next function, because I've not introduced you, so if you guys want to go back, if you want to, obviously, if you want to go back here and just say console.log and say hi, now there will be no other box. There will be no box popping up because I'm saying, hey console, please log this bit of string for me, this bit of text for me. And it's just putting it right here. So that's what console.log does. So if we go back here, we'll see that this function is taking a text and it's logging it.
Could you please zoom in a bit on that, the function searches?
Hey! There you go. Is that better? Is that a bit better? Yes. So what I've done right here is, so what you'll immediately see is the bunch of comments. I would really, really recommend, if you haven't already read the comments, to actually look at everything that is not in a comment and try to figure out what it does before reading the comment. That is very useful practice as well, because it kind of gets you understanding what you're expecting from your function to do. Good. So now, if we've had a bit of a look at how these functions are working, we can try to dissect them. And how do we dissect them? Well, I was talking about the keyword, it's function. It has to have a name. Like you remember, our variables all have to have a label. Our functions will have to have a label as well. And it's usually their name. The name has to be as descriptive as possible. You would not like your function to be named function funny, because that won't be very descriptive for you, will it? And like, no amount of comments all the way through your text will tell you what funny will actually be doing. Whilst time to school, it's kind of self-descriptive what it'll tell you to do. And then you've got what I was telling you about. So your need to knows, or your inputs. So I need to know my speed and my distance. And these guys are called parameters, arguments, or easier and much easier to remember, input. Because we're working with input and we're getting output. And this, right about here, is where you will be writing your black box. Because if you remember a few slides ago, I said, it's not really interesting what's in there. You want to reuse it. But actually, the fun bit is where you're empowered to write what's in the black box. And this is what you're doing with the functions. This is writing what is inside the black box. And that's the function body. And essentially, we also have a bit of syntax, i.e. stuff that we have to worry about. Because like you asked about the semicolons and so on and so forth, functions have this very distinctive thing that they have to begin with a curly bracket and end with a curly bracket. That's pretty much it. That's what you'll need to build your own function. So if you try and go ahead and use the function, and we call using the function in programming terms calling or invoking the function. But it generally all means that you're using the function. There may be other smart words for it. It's generally call, invoke, use. And obviously, we want to use our speed. So for instance, if I said time to school is 7 and 10, then I mean my speed is 7 and my distance to school is 10. Now if I go the other way around, because my inputs are actually matched. And what do I mean by matched? Well, we'll see that 7 goes to speed, 10 goes to distance. But if I put them the other way around, that would mean 10 is my speed and the distance is 7. Is that okay for everyone? Does everyone understand the matching idea? If you have to have them in the same order. Good. So, let's go back to our REPL right here and see what we can do. So, I've already written the time to school. If you want to, you can go ahead and press either Control Enter or just click on this button right here and it'll get our time to school. Now, what I want you guys to do is I want you to quickly think of how you can, more or less, you can try to call / invoke all of the other functions and see what they do, play around with them a bit. But also, ultimately, I would like you to simulate the fact that your trip to school is actually going to consist out of, you're going to need a delay, a time delay. Say I want your delay to be 1.5. Let's assume that you are very fast and that you're getting your bike unlocked and locked back in 1.5 minutes. I want you to add this delay back up here in time to school. So you can go ahead and do that at your own pace. This is not following my thing. Whatever you have in front of you on your computers is actually your own version of it. So you can play around with it as much as you want. You can even save it after you're finished playing with it. And you can make your code prettier. There you go. It doesn't like the space. But I think maybe that answers your question beforehand. If I say prettier, it'll put a space. Therefore, it thinks it's prettier to have spaces rather than not. Cool. Does anyone want to tell me how to do this? Yeah? Yeah, that's right. A plus 1.5. But, you see, we've already made a mistake here, haven't we? Because this will run, and this will work perfectly fine, and it will do what I told you I want it to do, which is it will add the bit of delay. But what I'm not taking into consideration is, if you look at this a week later, what will you get from it? You won't know what happened. You won't know why that 1 plus 5 is added there, will you? But if I do this, then we'll know what we wanted. And we can change the delay as well. So that is one of the bits that programming is really, really nice for. And the variables as well. That's what I was saying. You can add there in the body of the... Yeah, right there. You can add there in the body of the function. That's actually what you need to say there. You can add whatever. You're not limited to a single sentence. You can add whatever. And you can modify it. Because now you will understand. But if we want to take this a step further, we can actually comment. You can actually comment that. And the person that will read this later on will understand much better what we meant. And this is one of the really important concepts that I'm trying to convey right now. It's that code is supposed to be functional, beautiful, it's supposed to be working, but it's also supposed to be understandable. Good. So if we go right ahead and play a bit more, then we'll realize that here we can call different functions. We can call our funky function, which is right up there. in our funky function, we'll say, hey, we'll pop a box. Because that's what we told it to do, right? We told it to alert us. And alert, if we remember correctly, popped up a box. Now, if we also remember, we had this thing where we want to play with user input, with names. And what I want you to do is get the name. The pre here actually predefined it too much for me. So I want you to figure out what we have to put in here in order to get a name like we did with the box up there and print it out with the print text. The print text, it's defined right up there. The print text is right up there. And what it does the console.log that I told you about. So the print text, if we do print text, then it'll print out Lucia right there. So what I want you to tell me is what to write in here in order to get that happening, in order to ask the user to get me something and print it out in the console. Anyone? Prompt. Cool. Let's see if that works. So we'll want our get name. Another thing that I really want to stress is that. It's perfect. That worked. But again, maybe you want it descriptive. So, what I was meaning to say is that I've showed you this idea here, that you need parameters, that you need inputs. But you will encounter, when you'll be reading some code, functions like this. Functions that do not take anything, but actually do stuff. Actually give you something. Therefore, it's like pressing a button and knowing what's going to happen. It's like pressing the start on your computer and knowing that it'll open, but you didn't actually give it any input, so to say. You didn't have to give it anything. Well, probably except electricity. But other than that, you didn't have to give it anything. It just did its own thing. That's basically the same thing. Good. So if we go right ahead, and now we've seen all of these functions, but they were small. All of these functions were really just play. They were toys. Feel free to play around with them as much as you want to, change them, rearrange them in every single possible way, call all of them, call them multiple times, one inside the other. It's all up to you. You can do alert, time to school. And that will just pop it up in the box, and it will be alert, time to school. But what I want you to take away is also that you will almost never have to write a full program from scratch. Almost never. You will see a lot of documentation. You will see that autocomplete, like I showed you just before, is your friend. And what do I mean by autocomplete? Well, I already have these beautiful possibilities for me that will just autocomplete entirely. There you go. It doesn't want to autocomplete if I mistakenly write that. Essentially, what I mean by that is that whenever you're looking for something, you can get it at the touch of a dot. You can see all of the options that you have to do with console, for instance. Or even like I did before, if you remember. Document, dot, rate. Like I did before to make that done, done, done appear there. If you do that, funnily enough, another done appears. But essentially what I want to stress is that you're going to encounter a lot of helpers. A lot of helpers that have already been written for other people, for you. by other people for you, because you can use anything on the internet, and that is also a really, really nice thing. Like this particular article, I love it. You should probably read it if you have the time. It says that being a good computer programmer boils down to knowing how to Google well issues, and that's kind of the gist of it. And again, if you're facing an error, if you're having a problem, if something goes wrong, i.e. you don't understand, so I've showed you operators, right? What is this? There you go. It's understanding. It's infinity, but maybe you don't know what it means. Or maybe you're just making an error. Maybe you're just doing something silly, like writing a bunch of words, because that's obvious. You're not always going to write correct code. But what you want to do is you want to be able to go ahead and just copy an error and paste it somewhere and hopefully get a good result. And funnily enough, you usually get a Stack Overflow answer. Obviously, that wasn't the correct answer, but you will generally find most of the answers to your questions on the Stack Overflow. Another thing that I really want to stress is we'll be talking about arrays. So is everyone okay with functions right now? Does everyone understand what functions are, what they're used for? Because functions are my favorite bit of programming, I have to say. Everyone's okay with that? Good. So when talking about arrays, and this is the last thing that I'm going to be talking about today. So arrays are really, really good because we can think of them as lists of values. That's basically it. That's the gist of it. And you want to hold more things at the same time in a place, then you're just going to use an array. And we can go ahead and create an array. Say var my array equals, we want to put a cat in there, we want a 42, we want a name, we want, I don't know, another number, we want a true. So that's my rat now. Okay. So we've put a lot of values into my array, and we want to access them. And how do we access them? It's easy. It's as easy as asking it to access a particular place. And what do I say? So what do I mean by I'm doing this? That is indexing. That is called indexing into the array. And obviously, as computer programmers really love zeros, we're going to start the indexing from 0. So it's going to be 0 is going to be cat, 1 is going to be 42, meow is going to be 2. You can think of this as a library, as a bookshelf, in which you have all of your books, and you know that Isaac Newton's is in 0. You know that programming in a nutshell is in 1, and so on and so forth. So you know them by index. And another point that I want to drill home is that you remember functions? And you remember the really nice things that you can do with them? Well, if I go ahead and I have my name again, then a nice function is that I can get name.length. There you go. Don't want that. There you go. So name.length. Actually, .length is something that someone has already cared about and did that for us. And another thing that I want to show you guys is that whenever you'll make this list of values, say array, and you're going to make it contain a bunch of different things, you want us to look at it, JavaScript and the console allow you to see this. And this is a much more friendly and intuitive way of understanding also how it works, because after you see this several times, you're going to realize that 0 is the first element, 1 is the next element, and so on and so forth. And it gives you a nice visual, and that is also one of the reasons I chose JavaScript as a language. It just gives you a really good visual. To also show you one of the really good things. So what will you want to do? Because I've taught you variables, I've taught you functions, but when are you going to use them? Well, take this for instance. Take the example that you're going to have to get the first, see which are the people who have their first name starting with A, for instance. So you're going to say, okay, name dot starts with, because we have the option. And you say it starts with. And what are we expecting this to do? Well, starts with is actually going to check if my name is starting with an A or not. And funnily enough, starts with L is going to be true. Now also, we have the other option, which is ends with. And that is not true. And this is also very case sensitive. So, starts with A is not going to fall. So, we have all of these great options. And like I told you before, you will have a lot of opportunities to deal with libraries and ready-made functions for you. And now let's get back to our arrays. So, think about the string again. Think about the name. So, what did I do there? So, if I want to get at my first letter in my name, you can think of my array as actually just a lot of characters put together, basically one after the other. And that is sort of the same thing that we were doing with array, right? It was basically putting cat, 42, and meow all next to each other. Well, it's about the same thing with the name. It's an L, it's an U, and so on and so forth. They're put together. So we can actually get at the single characters by indexing in the same way that we do with arrays. Isn't that cool? I really like that bit. It's really interesting because, as well, you can go ahead and have your array, if you remember this guy. So this guy now has cat in it as the first element. Can anyone tell me how to get at the A in cat? Anyone? So, the answer's right up here. And that's what I said. Cat is a name. I'm going to get at our cat. Cat. If I do cat 1, it's going to get at the A. So, to drill in, I'm going to need to do a rat. Let's name a rat now. 0 and 1. And that's going to get at my A. And now that's what I mean by programming gives you so many opportunities. It just lets you completely decide that. Well, look, I want to get the middle, or I want to get the character at index 1 in my first element of my array. And you can do that by simply using the brackets. That's what we use, by the way. The brackets are the very important indicative that you are indexing into your array. Good. And you can also have, like I showed you before, you can think of this guy as containing C, A, T, and so on and so forth. And this is a full name, and so on and so forth. Now, we're almost done. We're almost done. A few things I want to really drill into is that, first of all, I was talking to you about variables a lot. But it is very important, like I said with functions, that your variables are self-descriptive. Because you can have really, really bad code that goes like x equals 3, y equals 4, x plus y is sum, and so on and so forth. And this is all fine if you're never going to use your thing ever again. Because you won't understand what you meant when you said x and y. But if you make them understandable, if you give them good names, you will just completely be aware of what you're doing. And that is a point that I was also making with comments. If you think about what you want to do beforehand, say for instance, you know that you want to do a chore. But you first think about how you can do it. You don't go ahead and you just go to the washing machine and go like, okay, what do I do next? No, you think the whole process through. You can explain it easily in one sentence, what is the entirety of the thing that you want to do. And then, after you can do that, you can go ahead and code it up. Because it's much easier to see the big picture than to just start and stumble in small steps. Cool. And what is this slide all about? This is all about what you don't need to care about right now. I've chosen JavaScript, especially for this reason. It's very beginner friendly, and it will not care about these gory little things. And you won't have to worry about it at all. I'm just saying that you need to be aware of this. So if anyone has ever tried to learn German or any language with very rough grammar, then you may have encountered the us of actually trying to comprehend all of those. So we won't have to go with that. So that's it. That's it for today. Hopefully you've gotten a pretty good view of what variables are, what we can use in programming languages. What are the first words? We have numbers, strings, Booleans. We can use them together with operators. We can do stuff with them. We have these really cool things called functions that allow us to abstract away, to put our code into tiny little pieces and reuse them over and over again. And we have arrays. Arrays which are, hands down, one of the best things there exists in programming. So yeah, next time I'm going to talk about control structures. I'm going to talk about how you want to tell your program how to act in a different way. Like I said, if it's cold outside, you're going to put the scarf on. If it's not, you're killing it. If it's not cold, you're not going to put your scarf on. That sort of stuff. We're going to be able to tell the computer how to understand how to do that. And I'm going to talk about looping. So this array, if you look at it, you probably want to not index into it over and over again. You're probably not going to want to say my array 0, my array 1, my array 2, but actually be able to go through all of them at once. Wouldn't that be cool? And finally, we're going to talk about, lo and behold, the really nice piece of JavaScript, which is objects, but more of that later. Cool. Thank you.
Awesome.